Alright guys, good morning. Well, it might not be morning when you're watching this, but it's morning for me right now. So we are going to review the Chapter 2 Mastery from CC2, so Math 7. We're going to go one problem at a time just so you don't get too excited and start writing too many things down. Guys, make sure that if you're doing revisions, you don't just want to get the right answers down. You want to make sure you know why you made that mistake. So don't put this video on mute. Probably don't speed me up too much. Listen while we talk through these problems. So some of us didn't give enough details on number 1 because it depends. When you have a positive and a negative, it depends which one is bigger, right? As we always talk about when we're like doing the battle or the fight, if they don't get along, if the negative is bigger, the negative is going to win. If the positive is bigger, the positive is going to win. And if they're equal, our sum is going to be 0, and 0 is technically neither negative or positive. It is even, though, just, fun fact there, 0 is technically even. So Gina wants to do this without a calculator and quickly. It says in just a matter of a couple seconds. So here's the deal. If you spent time adding and then subtracting and you did it wrong. This should be faster than that. The technique that we're trying to look at here is recognizing opposite values. So if we zoom in here a bit closer, 2438 and negative 2438 are opposites, so we don't really have to do any math. We can just say, oh, they wipe each other out. They're 0. So the sum becomes the only number that we still have, 5280. Same thing with positive 2100 and negative 2100. So if I break my positive 2100, well, if I break my 2116 up into 2100 and positive 16, then I can just say, all right, well, this positive 2100 cancels out with this negative. Boom, 16. Same thing with the 250 and the negative 250. Break apart your 4250 or 4250 if I say it correctly. So we end up with positive 4000 and a big trap door that a lot of people fell into. The negative is the bigger one over here. So yes, when we subtract, we're going to get 1, but we got to put the negative back on because that is the larger value there. And number 3, when we talk about adding positives and negatives, we've done a lot of that, right? Put the negatives together, put with the positives, see who's bigger, have that battle. But when we talk about multiplication, there are posters in the classroom, guys. Reference the posters if you can't remember the rules. But when there's only one negative, if I have 3 times a debt of $2, like I owe you $2 and I do that 3 days in a row, like I'm borrowing money to buy lunch or something. Now I owe you $6. Same thing over here in part D. If I borrow $3 a day and I do that every single school day this week, that's 5 days borrowing $3 every day. Now I owe you $15. And part C, just more positive negative addition. Number 4, I would not have tried to do this in the space right here because this is tougher than multiplication. So number 4, I brought over here onto my graph paper, and I always start by copying the original problem down first. But again, I just want to go one problem at a time. So to make common denominators, I decided to break up because this is addition, and I know I can always add 4 on at the end, right? So I'm going to wait to do the plus 4 until the end, and I'm just going to work with the fractions to start. With denominators of 3 and 4, common denominator that we can make is 12. So make sure you do that multiplication on top and bottom for both of those fractions. So we get 4 twelfths and 9 twelfths. 4 and 13 twelfths would not be the appropriate way to write that. We need to convert that improper back to mixed, and we will actually get 5 and 1 twelfth. I keep wanting to ask if there are any questions, but you can't really ask me questions through the video. All right, so 6 and 4/5 minus 2, or 3 and 2/3. Guys, this is subtraction. So this is tougher, even if we start trying to subtract just like the mixed numbers. If I do 6 minus 3, the only way this is going to work out is if 4/5 is bigger than 2/3. And until we get common denominators, I'm not totally sure, right? I'm not totally sure. So I just make improper first. So remember, to make improper, we go the whole value times the denominator. Like if I had 6 pizzas and they were all cut into fifths, then add that with the numerator. So that gives me 30 plus 4 is 34. Keep that denominator. So 34 over 5. Over here, 3 times 3 gives me 9, plus 2 more gives me 11. Sorry, I'm going to make sure that this is out of the way of my little picture-in-picture. So we want to start by making these improper. Right, so now I have denominators of 5 and 3, so now I care to make the common denominator. And I realize, 15. We can get both of them to 15, so multiply by 3 over 3, multiply by 5 over 5. Get these improper fractions. You don't have to write it plus a negative, but I kind of like to, I don't know, make the reminder to myself. I don't know why, I just do it. So we get 47/15. And when I convert that back, if you want to, if needed, right, we didn't have to, but if you wanted to, 3 and 2/15. Moving on to part C. Same process there. Let's make improper. So 8 times 4, then plus 1 more, 33 over 4. 3 times 8, 8, 16, 24. Plus 5 is 29, 29/8. Make common denominators. Do the subtraction on top, keep the denominator on bottom. 37/8 converts back, to 4 and 5/8. And addition, like we said earlier, doesn't really need to become improper. We can break it apart. We can say I'm going to wait to add that 2 at the end. This is really our commutative property, saying I can move things around. Commute, to move, right? So I'm going to break apart the pieces. Then we decide to make common denominators. Then we add up the fraction pieces. And then I realize, 26 over 21 is really 1 and 5/21. So now I do that addition. 3 and 5/21. I'm going to take a little break here. So number 5, you were probably safe to do this work down here, but because I wanted to write out some extra details, I also took that over to my graph paper. And the reminder that, guys, I gave you on the test, absolute value. I don't know how I can make it any more straightforward for you. Absolute value asks distance from 0. We've talked a lot about distance has to be a positive value. Even if I'm going the wrong direction, I went 3 positive miles in the wrong direction. So this absolute value is going to become positive 8, because how far is negative 8 away from 0? It is 8 away from 0. 8 and 3 are both positive, so I'm going to team those guys up. Negative 2, I went ahead and color-coded in red, because you guys know I like to write my negatives in red. And we get positive 9 as our sum. For part B, paper's getting stuck. For part B, we want to add up the bad guys together, fight with the good guys. Unfortunately, the good guys overpower the bad guys here. C, some of us forgot that this is multiplication between a number and like a parenthesis that is telling us to multiply. You could also draw the multiplication dot between there, but you do not have to. D trips some of us up, and E especially trips some of us up, because we need to do the multiplication, then do the absolute value. But I think most of us still got this. Now, a reminder, a positive times a negative comes out to be a negative. If you had a negative times a negative, those would cancel and become positive, because the opposite of a negative is a positive. Right? So that's why that would happen. E was a big trapdoor for some of us. This absolute value works like parentheses, where we have to work from the inside out. So we have to do what's inside of it before we get to removing these bars, which is when we actually make values positive. So we first do the math inside and get positive 13. Then, how far is 13 away from 0? Well, 13. All right, so on problem 6, it looks like a lot of you guys took this to decimal, like 0.8 times 0.8. Some of us accidentally added that together and got 1.6, but remember, this is multiplication. So what we're going to do here, what I did here, was I set up 0.8 is actually 8/10 if we say it correctly. So I'm going to write that as 8/10. So I can do fraction times fraction. Now, some of us also recognize, well, 8/10 can reduce down to 4/5. That was also a good strategy there. So if I get 32 over 50, that can reduce down to 16 over 25, or some of you went ahead and did that. If we do this as a decimal, it comes out to be 0.64 or 64 hundredths. But because I was talking about fractions are better than decimals, I stuck with fractions here. Multiplying a fraction times a fraction, we talked a lot in class. It is just straight through the top, straight through the bottom. So 3 times 5, 5 times 7. Or some of you recognized that when we have a 5 on top, and a 5 on bottom, that would actually make a giant 1, and those would cancel each other out, and our answer would just be 3/7. Part C, we only have one negative value here. So, like that reminder on the other page, when you only have one negative involved in your multiplication, you're going to get a negative answer. So, our answer we know is going to be negative. Then I do the multiplication through. Again, some of us recognize that there was some reducing that we could do. You didn't have to, but you could. And part D. A lot of us goofed up part D, so we're going to talk about this for a moment. You should not, I shouldn't say you should not. It's really dangerous to try to do this multiplication broken up. So guys, my biggest advice, like I write up here, a single fraction is better. So to make 2 1/8 improper, 2 times 8 plus 1, so we get 17 over 8. And yes, they both have the same denominator. That doesn't matter here. So we multiply across the top, 7 times 17. Multiply across the bottom, 8 times 8. And if I reduce back to mixed number, it is 1 and 55/64. I'm going to move that to make sure that my picture-in-picture was not blocking that. And again, negative times negative. What is the opposite of a negative? A positive. All right, in number 7, part C got pretty tricky. So we'll go look at graph paper for that. Remember, the bottom is the sum. The top is the product, as I gave you this little reminder over here. If we call your numbers x and y, top is x times y, bottom is x plus y. So here we're just being asked, do the multiplication of 3 times negative 7, we get negative 21. 3 plus negative 7, we get negative 4. Man, you guys are coming into school already. I gotta hurry up. All right, so here we're trying to figure out what number multiplies with 2 to make negative 10. So we can kind of do that backwards and say negative 10 divided by 2 is negative 5. And then when we add those, we get negative 3. 7C was kind of like a puzzle. So we know that our numbers A and B, or X and Y, whatever you want to call them, multiply to make 24. And they got to add to make negative 10. So I know that how could I make a positive 24? A positive times a positive, or a negative times a negative. So how could I make negative 10 a negative plus a negative, like two bad guys teaming up, or a big negative and a small positive? So which of these options jive with both of these and let me do and? Well, negative, negative, right? Negative, negative will multiply to make the positive I want and add to make the negative I want. So I can start testing out factors, or I could start testing out things that can add to 10. But if I start testing out factors of 24, I eventually see, 4 and 6 will add to 10, so I just need to make those negative. Negative 6, negative 4 makes negative 10, also multiplies to positive 24. And then number 8, guys, a lot of us goofed up on these smaller values. So, like 3/8. We talked about 1/8 is 0.125. Every single eighth is 0.125, so 3/8, 0.375. This is where it gets goofy, when we have decimals involved in fractions, right? So come see me if you need some extra help on this. And I think most of us got 9 and 10 correct. So I'm just going to show those here and cut the video off because I got people in the hallway waiting to come in and ask me questions. So remember, when we get out here, there's more age. When we get up here, there's more value. So the closer we are to 0, the newer or the more worthless it is. So like when we have this worthless painting. All right, but I'm going to cut it here because this was already about twice as long as I wanted. So come see me if you need more help. Aside from that, have a great day. Get those revisions turned in as soon as you can.